In 2013, Explorer 1 accomplished a surprising achievement by becoming the first human-made object to enter interstellar space. This extraordinary accomplishment happened 36 years after its takeoff from Earth. The spacecraft presently resides 14.5 billion miles away from Earth. In about 2 days, NASA engineers receive messages, never having thought that Explorer 1 would continue its space exploration for nearly 50 years. Explorer 1 identified 500 unidentified objects moving through space, igniting immense conversation. Notably, popular podcaster Joe Rogan joined the discussion to shed light on the disruptive implications of this uncommon discovery. These strange objects could have been created by creatures from other worlds or been a malfunction of the spacecraft, a topic that has captivated researchers for a very long time. Recent extraordinary encounters in deep space have sent shockwaves through the scientific community, possibly revealing insights into the long-standing issue of extraterrestrial life. Joe Rogan, a prominent reporter and podcaster known for his distinct interest in examining extraterrestrials and the possibility of advanced civilizations, has previously hosted guests like David Grush and others to explore the potential for life beyond Earth. The notable Explorer 1 mission was conceived in the 1970s when NASA researchers had the chance to truly comprehend the vastness of our immense universe. It all began with an unlikely alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. A young PhD student named Gary Flandreau discovered an extraordinary celestial phenomenon that would guide space research in the late 1970s and early 1980s. The 4 planets aligned in a stunning arrangement that looked like pearls on a great necklace, with Earth nestled among them. This discovery sent waves of excitement through NASA as it presented a unique opportunity to streamline the trajectory of a spacecraft by cleverly utilizing the gravitational pull of each planet during flybys. Flandreau estimated that these gravity assists from the giant planets could shorten the flight time from Earth to Neptune from 30 years to just 12 years. However, this celestial alignment occurred only once every 176 years, prompting NASA to embark on an ambitious mission to capitalize on this once-in-a-lifetime chance. Explorer 1 and Explorer 2, twin spacecraft launched in 1977 to investigate the mysteries of the solar system, were launched 15 days apart. Elements of NASA's Explorer spacecraft program, a testament to humanity's insatiable curiosity and quest for knowledge. For nearly 50 years, Explorer 1 has been transmitting valuable data back to Earth through NASA's Deep Space Network, bridging the divide between our earthly existence and the secrets that lie beyond. Currently, Explorer 1 is 24 billion kilometers away from Earth, standing as the farthest human-made object from our planet. The spacecraft was meticulously designed and developed using NASA's Jet Propulsion Laboratory and began its historic journey from Launch Complex 41 at Cape Canaveral Air Force Station, propelled by a Titan IIE launch vehicle. One key feature of Explorer 1's launch was having redundant computer systems. Both Explorer 1 and its twin, Explorer 2, were equipped with 2 sets of command computer subsystems, Flight Data Subsystems FDS, and Attitude and Articulation Control Subsystems ACS. This redundancy ensured smooth transitions between systems and the ability to activate dormant computers when necessary, thereby extending their lifespan. The computer systems on board the spacecraft were arranged as a distributed system with 3 redundant sets of computers, ensuring that if one system failed, the others could seamlessly take over, preventing critical failures. Power management is a crucial aspect of maintaining the operational integrity of Explorer 1, especially as the distance from the Sun, where it can harness solar power, presents significant challenges. Engineers had to devise innovative ways of monitoring and optimizing power usage, including implementing specific power shutdowns for non-essential systems. In summary, Explorers 1 and 2 have been instrumental in uncovering the secrets of the nearby solar system and interstellar space, providing pivotal insights into space's vastness and the mysteries that lie beyond. Recognizing that Explorer 1 is a space probe that has defied all odds, transmitting vital information nearly 50 years after its initial release, expected to last only 5 years, Explorer 1 has been equipped with a wide array of scientific instruments and subsystems. These instruments were strategically placed on the spacecraft's body, which contains an astonishing 65,000 individual parts. One of the durable instruments on Explorer 1 and Explorer 2 is the low-energy charged particle detector. This instrument boasts 3 sets of particle sensors that measure the number of low-energy particles striking it, as well as their speed. It continuously monitors high-energy radiation and particles from the Sun, planets, and interstellar space. The Cosmic Ray Detector, a companion instrument, actively searches for high-energy particles from both the Sun and other celestial sources. The Plasma Wave Subsystem, which consists of 2 extended radio antennas arranged at right angles to each other, serves as a critical tool for measuring the electric field potential and wave components encountered at the outer planets. However, its role has evolved as the explorers ventured into interstellar space. Over the years, engineers have made improvements and advancements in technology and power management techniques, including more efficient power distribution, enhanced battery charging methods, and changes in how power is controlled. Explorer 1 continues transmitting crucial information, demonstrating the dedication and inventiveness of the engineers and scientists who have worked relentlessly to keep it running. The Explorer missions, initially designed to investigate the magnetic fields of the outer planets, have undergone significant changes as they make their way into interstellar space. The magnetometer, originally focused on the magnetic fields of outer planets, now plays a crucial role in studying the transition region between interplanetary and interstellar media. This instrument is used to examine the magnetic properties of the transition zone, the boundary where the Sun's magnetic influence gives way to the magnetic field of interstellar space. The Plasma Science instrument, which analyzes low-energy particles within the plasma, is currently only available on Explorer 2. This instrument embodies NASA's ongoing scientific investigations. Both spacecraft's radiators were turned off after 21 years of operation, and non-essential instruments have been permanently turned off. The power source for each spacecraft consists of 3 radioisotope thermoelectric generators, RTGs, which use the heat generated by the radioactive decay of plutonium-238 to produce power. As plutonium-238 continues to decay, it will eventually be unable to provide power, leading to the suspension of all instruments around 2025. To extend the operational lifespan of both spacecraft until 2027, the Explorer team is employing careful techniques for controlling power. Each spacecraft is equipped with transmitters to maintain communication with Earth, and the primary transmitter emits about 20 watts of power. However, the strength of the signal from Explorer 1 reaching Earth's strength is 20 million times that of a modern battery for a wristwatch. Explorer 1's journey through space has not only expanded our understanding of the solar system, but it has also supplied crucial insights into the nature of the charged bubble that is the heliosphere, the Sun's surrounding particles. As Explorer 1 moved further from the Sun, it began to encounter different environmental conditions than those encountered by earlier spacecraft. One of its perhaps most significant contributions has been its role in mapping the structure of the heliosphere and its boundary, known as the heliopause. This boundary marks the transition between the wind from the Sun and the interstellar medium, where the Sun's influence wanes and material from other stars begins to dominate. Its plasma wave instruments data, Explorer 1 has helped scientists better understand the behavior of plasma in this transitional zone. This information is necessary for comprehending how cosmic rays that come from beyond the solar system interact with the heliosphere and how space weather is affected by these interactions. Such insights are vital not only for space science but also for safeguarding future spacecraft and astronauts from harmful space radiation. Another important feature of Explorer 1's mission is what it does for the study. As Explorer 1 crossed the boundary into interstellar space, it provided the first direct measurements of the Sun's magnetic field beyond its influence. These measurements have been instrumental in enhancing our understanding of the magnetic environment of the interstellar medium. The collected data aids scientists in modeling the magnetic interactions between various parts of space and learning how these interactions influence large-scale phenomena. Explorer 1's longevity and continued data transmission have also played a role in an improved comprehension of the properties of dust from other stars. The spacecraft's dust detector has been crucial in measuring the density and speed of interstellar dust particles. These measurements provide helpful details regarding the composition and distribution of dust in our galaxy, which in turn influences theories about star formation and the evolution of the interstellar medium. The spacecraft's ongoing mission has also shed light on the advancement of technology used in space engineering and exploration. The achievements of Explorer 1's mission have established a standard for future deep space missions. The innovative design and resilience of Explorer 1's systems have influenced the development of subsequent spacecraft, illustrating how engineering solutions can enhance the longevity and far-reaching effectiveness of space missions in addition to exceeding initial expectations. In addition to its scientific achievements, the message carried by Explorer 1 is symbolic for any potential alien civilizations. The golden record, containing sounds and images designed to represent the diversity of life and culture on Earth, serves as a universal salutation and an affirmation of humanity's desire to connect with others and spread its presence within the cosmos. This message, along with the data from the spacecraft, is a monumental step in humanity's quest to explore the universe and engage with intelligent life beyond our planet. In general, the Explorer missions have advanced significantly in their exploration of interstellar space and the mysteries surrounding the discovery of 500 unidentified objects. Explorer 1, a space probe, has identified 500 enigmatic objects in the bowels of space, which caused a lot of concern among scientists. Initially, data sent back to Earth was distorted, resembling a garbled message from the universe. NASA's Jet Propulsion Laboratory was perplexed by the confusion and found that the Attitude Control and Guidance System AACS had switched to using a malfunctioning onboard computer that had been dormant for years. This caused distorted telemetry data. NASA engineers quickly processed the telemetry data, changed the AACS to fix the problem, and transmitted data through the correct computer. Uncorrupted data from Explorer 1 is now streaming back, but the question remains, what caused the AACS to use the faulty computer? NASA researchers have yet to provide a definitive answer, but have proposed a theory suggesting the AACS received a corrupted command from another onboard computer. Susan Dodd, Explorer's interstellar mission, revealed that a complete memory readout of the AACS would be conducted, followed by an extensive assessment of its activities to determine the root cause of the telemetry issue. Several factors could contribute to the anomaly, such as environmental conditions of space, cosmic radiation, temperature changes, and exposure to dust and other tiny meteorite particles and debris from asteroids and comets. As the first Explorer ventures into interstellar space, its plasma wave instruments have always been able to detect the effects caused by dust particles' high spiral speed. When a dust particle comes into contact with the spacecraft, it disintegrates and ionizes, creating an expanding plasma cloud that initiates a voltage pulse in the spacecraft's plasma wave antenna. In contrast, other types of hypotheses have been proposed to explain the telemetry anomalies in Explorer 1's systems. One possibility that has captured the imagination and belongs to science fiction exists in the involvement of extraterrestrial beings. However, this theory is highly speculative and not widely accepted by the scientific community. The concept of intelligent life from other planets has intrigued scientists and space enthusiasts alike. Joe Rogan, a prominent podcaster and media figure, has explored this topic through conversations with scientists and UFO enthusiasts, especially David, an ex-Air Force intelligence officer and representative of the National Awareness Office for Unidentified Aerial Phenomena. The UAP group discussions have fueled interest surrounding the anomalies observed in Explorer 1's data. Rogan believes that in a vast universe with billions of galaxies, stars, and potentially even more planets, the possibility of intelligent civilizations elsewhere in the universe raises fascinating questions about their potential interactions with humans. If these extraterrestrial beings were to meet an explorer, they may have observed the spacecraft as it moved through the universe and chose to look into it, perhaps out of pure curiosity. This scenario hints at the possibility that the anomalies could be a way for them to send an eternal message, a form of interstellar greeting. The Golden Record, a surprising artifact on board Explorer 1, serves as an interstellar time capsule designed for any intelligent beings that may come across it. If extraterrestrial beings had access to the Golden Record, they would interpret an abundance of information about Earth's cultures, languages, and the staggering variety of Earth's life. This raises fundamental questions about how they would interpret our music, art, and what they might make of our languages and scientific understanding.